Okay, now that we understand what average atomic mass means from the periodic table and what a mole is, we're going to put these two concepts together to start using those values to do some calculations in chemistry. And the first thing we want to look at is what we refer to as molar mass. And again, that's going to relate our grams of a compound to what we know as the moles of a compound. Okay, what you're looking at is simply a block from the periodic table, and obviously this is lithium. As we talked about before, we know that there are always three pieces, at least, of information in each block on the periodic table. Obviously, you're told the chemical symbol, which tells you that this is lithium. Then you are told the atomic number and the mass number. And you don't want to think of it as the atomic number is the one on top or the one on the bottom. You want to think of it as the atomic number is always the smaller number and it's always the whole number. The mass number is going to be the larger number and it's also not going to be a whole number with a few exceptions. What we're interested in right now is this mass number. So when you're looking at the periodic table, that mass number, we've always said, has had units of AMUs. Well, now what we're going to say is that mass number has units of grams per mole. What that means is if you took 1 mole of lithium, and we know what that is now, that would be 6.02 times 10 to the 23rd atoms of lithium, and you put that on a balance, the balance would read 6.941 grams. So we have 6.941 grams of lithium for that mole of lithium. So when you look at the periodic table, you look at the mass number, and then the units are grams per mole. So for example, if you're looking at carbon, its number on the periodic table is 12.01, and that's grams per mole. So as I'm sure you can tell, what we're going to do is use these units to help us with our calculations for the rest of this course. Okay, so let's just review quickly. We said that the mole is 6.02 times 10 to the 23rd, whatever we're talking about, and then we use the mass number on the periodic table to tell us how many grams per mole that element has. So for example, if you look at nitrogen on the periodic table, its value is 14.01, and again, the unit is grams per mole. Now when you have compounds, such as water, to calculate what we refer to as the molar mass of water, that's how many grams there would be in 1 mole of water. In other words, if you had 6.02 times 10 to the 23rd molecules of water, what would its mass be? So if you've got H2O, that means you've got 2 hydrogens and 1 oxygen. Well, if you look on the periodic table, hydrogen has a mass of 1.008 grams. Oxygen has a mass of 16. So for the hydrogen, you've got 2 of them, so you have to account for that. If you add that all up, you get 18.02 grams. If you look at a compound like barium nitrate, now the difference here is you've got that polyatomic there with a subscript behind the polyatomic. So you just need to account for everything. You've got 1 barium. Now, since this is in parentheses and there's a 2 behind there, that means you've got 2 of this entire thing. So you've got 2 nitrogens and 6 oxygens. So our mass of barium from the periodic table is 137.33. You've got 2 nitrogens, like we said, 14.01, and you've got 6 oxygens. So when you add that all up, you get 261.35. So if we look at a couple of examples, and you should have your periodic table handy, if you're calculating the molar mass of these items here, If it's a single element, you just look at the mass number from the periodic table. So for nitrogen, it's 14.01, and again, that's grams per mole. If you looked at potassium, its value is 39.1 grams per mole. Usually going to the tenths place is fine. If you want to take it to the hundredths place, that's fine also, but going to the tenths place is usually fine. Okay, so for water, we said we have two hydrogens. Their mass on the periodic table is 1, plus 16 for oxygen gives you 18 total grams per mole. For the C3H8, we have 3 carbons. If you look up carbon, you'll see its mass is 12. Now notice on the periodic table it's 12.01, but again I said the tenths place is fine, so we can just call that 12 plus 8 times 1. So we have what? 36 plus 8. We have 44 grams per mole. Now we've got another one of these where we have a parentheses. So we've got 1 calcium, and if you look up its value, it's 40, plus how many oxygens? In parentheses with a subscript of 2, so there's 2 oxygens, each of those are 16, and then you've got 2 hydrogens, each of those 1. So we have 40 plus 32 is 72, plus 2 is 74 grams per mole. Okay, now we've got aluminum sulfate. And again, it looks more complicated, but it's really the same exact procedure. You've got 2 aluminums, so if you look up their value, 27. You've got 3 sulfurs. If you look up its value, 32. And then you've got 12 oxygens. Notice, subscripts multiply subscripts. So 12 times 16. Put that into your calculator, and you get 342. And again, the unit is grams per mole. So as you can see, calculating molar mass is relatively simple. The tricky part is just understanding that what you're talking about is the mass of that element or compound if you had 1 mole of that compound. So what we can do with this is we could make this a little bit trickier. We could say calculate the number of copper atoms in 63.55 grams of copper. So let's start with what we have, 63.55 grams of copper. Now we're going to do these problems using dimensional analysis again. So remember, if we're starting with grams of copper, we want that unit in the denominator so we can cancel it out. Well, our relationship with grams and copper, we know, if you look at your periodic table, that there's 63.5 grams per copper for every mole of copper. Because on the periodic table, it's 63.5 grams per mole. Now, it's just coincidence here that we started with 63.5 grams of copper. So your grams cancel, and the units we have right now are moles. Well, we don't want moles, we want the number of copper atoms. So we're going to do one more conversion. We have moles up here, we want to get rid of it. Now, do you remember how we go from moles to atoms? What the conversion was? 1 mole, 6.02 times 10 to the 23rd atoms of copper. So our moles cancel, and when we do the math, we have atoms as our unit. So as you can see, 63.5 divided by 63.5 is just 1. So our answer is actually going to be Avogadro's number, and again, that's coincidence. It's just the way the problem was set up. Okay, let's take a look at one more example. Which of the following 100-gram samples contains the greatest numbers of atoms? So what you're going to do is all three of these the same way. You've got 100 grams of magnesium. We're going to convert from grams. The only thing we can go to from grams is moles. If you look on the periodic table, it's 24 grams of magnesium per mole. Grams cancel. Now we have moles, and then we're going to say 1 mole magnesium, 6.02 times 10 to the 23rd. Atoms, moles cancels, so 100 divided by 24 times 6.02 times 10 to the 23rd gives us 2.5 times 10 to the 24th. Okay, so then what you're going to do is the same thing with zinc and silver. You're doing the same process. The one that has the most number of atoms then is the one that will give you your answer. So for example, if you were doing zinc, you would say 100 grams of zinc. We want to get rid of grams, so that goes in the denominator. On your periodic table, zinc has a molar mass of 65.4. And again, that's per mole of zinc. So our grams cancel. And we want to go from moles of zinc to atoms of zinc. And then you can complete the math. Okay, so as you can see, calculating molar mass is very easy. Again, the important part is understanding the units for molar mass being grams per mole. So you look at the periodic table, you get the mass number, and then it's the units grams per mole. So for example, boron would be 10.8 grams per mole.